Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for another session in aldehydes, ketones and carboxylic acid. Today we are going to see some of the important questions, that two objective type of questions with answers, right? Let us see the first question now. Among the following acids, which has the lowest pKa value? Okay, so we are having some options here, right? And we are supposed to find out which acid is having the lowest pKa value. For that, first we should know what is a pKa value. See, it is a number that describes the acidity of a particular molecule. That means this pKa value measures the strength of an acid by how tightly a proton is held to a bronzed acid. Okay, the lower the value of this pKa value, stronger will be the acid and greater its ability to donate the protons. Okay, so in this question, all the acids, see here we are having four types of acids, is it not? So in all the acids except this formic acid, that is HCOOH formic acid, all are having alkyl groups, is it not? So all the acids are having alkyl groups. See, these alkyl groups are electron repelling groups. Okay, so since they are electron repelling groups, they decrease the acidic strength of an acid. Understood? Since they are electron repelling groups, they decrease the acidic strength of an acid. But this HCOOH, that is the formic acid, this does not contain any alkyl group here. Therefore, it is the strongest acid of all the given acids, and this has the lowest pKa value. First itself I told you the acid which is having the lowest pKa value will be the strongest acid. So this formic acid is the strongest acid since it is not having any alkyl group. So there is no repulsion, okay, of electrons. Okay, acid, that is the formic acid, is having the lowest pKa value. Understood? So the correct answer is a formic acid, right? The next important question is, when CH2 double bond CHCOOH is reduced with lithium aluminum hydride, the compound obtained will be. See here we are given an unsaturated acid and they are asking, when this unsaturated acid is reduced with lithium aluminum hydride, what compound will be getting. So four types of answers we were given. Okay. See, normally the COOH group, okay, normally the COOH group which is present here, when it is reduced by any of the substance, the COOH group on reduction will give alcohol, okay, it will give alcohol, understood? So the COOH group will be getting converted to alcoholic group. Can you understand? See, here in this option we are having the carboxylic group, here we are having the alcohol, here also we are having the alcohol, and here we are having aldehyde. So the answer could be B or C, not. But see, this lithium aluminum hydride has a peculiar character that it does not disturb this carbon-carbon double bond. Can you understand? While reducing the acid, this lithium aluminum hydride will never disturb the carbon-carbon double bond. Okay, it reduces only COOH to alcohol. In that case, see, B will be the correct answer because in B the double bond, carbon-carbon double bond is as such, there is no change here, only the COOH group is getting converted to OH group. But whereas here in this case, here this is also getting, the double bond is also getting reduced, is it not? It's getting converted to a single bond. So this is not the answer. So option B is the correct answer. Can you understand? Next question, consider the following reaction. RCOOH. RCOOH is nothing but it's an acid. Okay, so this is an acid, and ROH, this is an alcohol. Okay, so an acid is treated with alcohol in the presence of mixture gas. We are getting RCOOR dash plus water. What is RCOOR dash? It is an ester. Okay, so it's an ester. So when an acid is treated with alcohol, we'll get ester. Can you understand? Now, which of the following statement is not correct? See, they are given the reaction and they are asking you to find out which of the following statement is not correct. Okay, so obviously here the acid and the alcohol, they are reacting and they are finally getting converted to an ester. Okay, so let us see the first statement. The reaction is called esterification. Yes, obviously this is a correct statement because here obviously we are getting an ester. Acid reacts with an alcohol, it is giving ester, so it is esterification. It's a correct statement. Next one, the equilibrium can be shifted to the right by using an excess alcohol. Yes, of course, the equilibrium can be shifted towards the right by using an excess alcohol and also by removing water. Okay, by removing water continuously from the side. When water is continuously removed, also we'll be getting this reaction will be getting shifted to the right. And also, if we are using excess alcohol also, this reaction will be shifted to the right. Okay, so this statement is also correct. Okay, what's the next one? The rate of the reaction decreases with increase in the size of groups R and R dash. That is also correct. See, if the size of R and R dash are increasing, obviously the rate of the reaction will be decreasing. Okay, so this statement is also correct. So let us see the final statement. The reaction involves the cleavage of OH bond of the carboxylic acid. No, it is wrong because the reaction involves the cleavage of the OH bond of alcohol. Okay, cleavage of alcohol and not carboxylic acid. So this bond will be getting, so this will be breaking. Okay, and not this one. Okay, so this statement is the wrong statement. So the wrong statement is one, that is the reaction involves the cleavage of OH bond of the carboxylic acid. This carboxylic acid OH group will not be undergoing any change, rather the ROH, that is alcoholic OH, will be undergoing cleavage. Can you understand? Next important question, the product formed by the reaction of an aldehyde with a primary amine is. So what product is formed? The question is, what product is formed during the reaction of an aldehyde with a primary amine? Either it's a Schiff's base or ketone or carboxylic acid or aromatic acid. So let us see an example now. See, let us take a benzaldehyde C6H5CHO. Okay, benzaldehyde, it's an aldehyde, right? And we'll take a primary amine. Since it is an aromatic aldehyde, I'm taking an aromatic amine, that is aniline. Okay, NH2. So this is aniline. This is nothing but C6H5NH2. Okay, aniline. So I have taken aniline. So this is benzaldehyde. What's happening here? There will be removal of water molecule. Okay, so removal of water molecule, and this reaction takes place. Okay, when we are heating this reaction takes place. So let me write the product now. CH double bond N, then again a phenyl group. Okay, so plus water molecule. Okay, water is removed. So this is nothing but benzol aniline. Benzol aniline is nothing but Schiff's base. Okay, it's Schiff's base. Alright, so the correct answer is Schiff's base. Okay, so the product formed during the reaction between an aldehyde and a primary amine is Schiff's base. Can you understand, students? The next one is, in the following sequence of reactions, you are asked to find out product C. See here, what's the reaction happening? Toluene on a reaction with KMnO4, it gives A. When this A is treated with thionyl chloride, we are getting B. When this B is treated with palladium and barium sulfate, that is when it is reduced in the presence of palladium and barium sulfate, we are getting C. And the question is, you are asked to find out the product C. We were given 4 options. Okay, as it. So let us see one what is happening during all these reactions. First, let us find out A, and then B, and then finally C. Okay. So what's happening when toluene is treated with KMnO4? Okay. So this is toluene CH3. Okay. When it is treated with KMnO4. So what happens when it is treated with KMnO4? It undergoes oxidation. Okay, this toluene undergoes oxidation. Okay, so when toluene is subjected to oxidation in the presence of KMnO4, the alkyl side chain attached to the benzene ring, see the alkyl side chain attached to the benzene ring always gets oxidized to COOH group. Can you understand? So this gets converted, the CH3 group gets converted to COOH group. COOH. What is this? This is a benzoic acid. Okay. So this is benzoic acid. So we have found out A now. So we have found out A. A is nothing but it is benzoic acid. So now let us see what is happening when it is treated. This benzoic acid is treated with thionyl chloride, SOCl2. Okay. See here. See, for you to understand easily, I am breaking this SO2 SOCl2 as ClCl. Okay. So now what's happening here? See, this one of the Cl is getting attached. This H is getting attached to this one, and this Cl is getting attached to this COCl, and this oxygen is getting attached to this SO. So what are the product we are getting? COCl. Okay, plus see here this oxygen is getting attached to this SO. So we are getting SO2. Can you understand? Plus, what's happening here? This hydrogen is attached to this Cl. Is it not? So, HCl. So, these are the products we are obtaining. So, what's the name of this compound? This is nothing but a benzoyl chloride. Benzoyl chloride. Can you understand? Benzoyl chloride. So, what is B? B is nothing but benzoyl chloride. See this benzoyl chloride, which when treated with hydrogen, okay, then palladium and barium sulfate, when this reaction is taking place, what's happening? See here, this hydrogen, for your understanding, I'm splitting this hydrogen as like this, okay. So what's happening here? This hydrogen is attached to this one, and this chlorine gets attached to this one. So we are getting the product like this. CHO, okay, CHO plus HCl. Can you understand? See here, this hydrogen is getting attached to this O. So CHO, and this Cl is getting attached to this one. So HCl. So we are getting benzaldehyde. What's the name of the compound? Benzaldehyde. So C is nothing but it is benzaldehyde. So here the option D is correct. Benzaldehyde, C6H5CHO. Benzaldehyde is the correct answer. Can you understand, students? Well, fine, students. I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from you. Thanks for watching.